I'm Carl Robler.
I'm Prash Shabrolkar.
And we're both program managers at Microsoft. I'm on the customer advisory team working with our largest, most complex customer environments. And Prash is a PM responsible for?
I'm on the reporting services program management side, dealing with SharePoint integration, manageability in reporting services.
So before I start here, we've both walked around a little bit and chatted with some of you. We do encourage this to be an interactive session. This is the last session of the day. If you want to move a little closer so you can ask questions, that we would encourage that. We've got a lot of stuff we can cover here. We don't intend to get through every slide in the entire slide deck. We do want to encourage you as we get to a certain section where you have specific questions. There's probably more than we can talk about than what we're going to talk about on the slide directly. So if you've got a question that applies to your environment, ask a question, please. I know I talked to a bunch of you, but how many of you are deploying reporting services in native mode only? Please raise your hand. How many are doing SharePoint mode only? Couple. How many are doing SharePoint and native mode? Oh. Okay. How many of you are already doing some version of scale out, or stop right there. How many of you are doing some version of scale out already? And the rest are here because you're anticipating you're going to need to do scale out. Okay. So the objective is to provide you guidance on how to scale out reporting services. We're going to talk about both SharePoint mode and native mode, and talk about best practices on RS catalog, scale out deployment, and various performance optimizations. So the order, by the way, of the session, I was thinking about that today when we're going through this. Right now we're going to go through the architecture in general of your scale-out choices and then dive a little deeper into different places that you can do scale-out and a couple places where we're going to recommend scale-up. This assumes that you actually need to scale up. The idea of scale-out is essentially that as you get more users on your system, you're going to need more power to handle the requests as they come in. This assumes that you've got optimized reports. There's things you can do to do some additional optimization. This is not a talk about how to optimize reports. We have one slide we're going to talk about it. But the entire deck basically assumes that you've already done your work to optimize. You're not doing inefficient things, pulling too much data back. You're doing smart things. And you actually still need to scale out because you want to handle more concurrency. You need to handle more simultaneous reports. So we're starting with native mode. This is sort of the scenario that you can put together here. You have multiple clients. I'm sort of reading from left to right. You've got multiple clients that want to connect to reporting services. And since we have, on the RS scale-out deployment, we've got 3 RS application servers, front-end servers. This is the RS application. With 3 of these here, you want some kind of NLB in front of it. So when your clients come in, they connect to the NLB, and it will route them to one of the 3. We'll talk more in detail about each of these points. It hits the RS application server. The RS application server, whichever one it hits, goes to the RS catalog, retrieves the metadata for the report, and then goes and assuming you're doing a live report and not a snapshot, a historical snapshot, it'll go back to the underlying data source and pull that data back. So if you see, basically seeing here, there's one report catalog, but you can scale out to multiple front-end RS servers.
Okay. So as Carl was saying, every different clients can actually, when they connect to reporting services, say, I want to render a report. So what exactly happens? This is what this particular data flow is about. So first, starting left to right, first the report server will have the authentication request that comes in, authenticate the user. Once the user is authenticated, they want to access an RDL. Once the RDL access check is passed, then report server essentially goes to access the report definition, or the RDL, from our catalog. After getting the RDL from the catalog, It passes the query engine, which needs to execute the query. And for that, it needs to connect to the backend data source. That is the second arrow up that you see above. And then the RDL plus the data source will result in the output that gets provided to the user to actually view either in the browser, or if you have your own embedded report viewer control, or your Win32 app. So that in essence is end-to-end. Here's the workflow. User logs in or renders a report. RDL is retrieved from our catalog, and the data is retrieved from the backend data source, put together, and the output is provided to the particular user.
And the reason we're focusing on here is to make sure you're thinking about, as you start to scale out, you're starting to talk about more servers. You've got more hops that are going on. So it's important that you understand you are paying a price for essentially the scale-out solution, because you're going to be hopping across multiple machines. We'll come back to that some more.
So let's take a look at SharePoint mode. It gets a little complicated there, where the NLB actually is now communicating first to the scaled out, if you have a scale out of your web applications or web front ends. So you have SharePoint that's scaled out. Now, how do you get from the web front ends to the app servers or the actual report server running in the mid-tier? So there is a property that we provide called the report server URL. Now, if you have a virtual or you have the NLB, then you would provide that virtual URL as that one report server URL. That then has the ability to physically route it over to the individual report server app servers. There is no inbuilt load balancing in report server in SharePoint mode until Denali, where we do have an inbuilt round-robin load balancer. And then you do not have to deal with the additional NLB in the middle. Is there any questions? OK. I thought there was a question. But then access to the backend, the mid-tier is important, because now we have not just the report server catalog or the report server tempdb, which is the RSDB that you see there, but we also try to access our content inside SharePoint content and config databases, which is also shown here. And all the various scaled out app servers need access to both the sets of databases. So basically the intent is to, again, as Carl was saying, here are the various data flows, and every time a flow is made from whether the client to the web front end, to the app server, to the catalog, this introduces a hop. And before, pre-Denali, in the mid-tier, if you required Windows identity end-to-end, then you would have to set up Kerberos in the mid-tier to ensure the double hop is taken care of. I was talking to one of the gentlemen behind, and they needed to set up Kerberos, and that was one of the issues that they had to do for taking care of the hop. So in SharePoint mode, I actually went left to right. But let me explain in detail. So when a user actually logs into SharePoint, on the web front end itself also makes SharePoint catalog calls to actually make sure that to authenticate the user, as well as to retrieve the RDL. So in SharePoint mode, the RDL, the reports themselves, are stored as any other items inside SharePoint, like a doc or worksheet. So it does a catalog access. Then we have a proxy that sits in the web front end. It is a reporting services proxy that forwards the request over to the backend, SSRS server. And that does the same, as I said before, is first, in order to retrieve the RDL, it goes to a catalog. And then once it has the report definition, it needs the data from the query, and then access the backend data source, where based on the credentials you provided, and then that data gets passed from the server, the output, to SharePoint, back to the client to view.
So I want to make a comment here. First thing is there's a paper that we published between the CAT team and the product team about some performance implications of running in SharePoint mode. One of the key things we've learned in studying it in general, and there's some specific issues we'll talk about in a moment, but because of the extra overhead of SharePoint and the extra hops involved, that there's an implicit amount of overhead in just getting going. So for short-running reports, if you're comparing them from native mode to SharePoint mode, they're going to take longer in SharePoint mode. In addition, there's a lot of other work that is going on in Denali that's going to do a lot to improving performance. But just this architecture itself will explain some performance implications, particularly as you start scaling out to the full scale out that we're diagramming here.
Sure. Yeah, there's a question, yes.
Yeah.
Kind of 2 slides back in the native mode. We've got queries that are executing for so long that the round robin is kind of doing us a disservice because it'll route a request to a server that already has full memory allocation, and I mean it's already running as much as it can. It can't handle more requests.
What load balancer are you using?
That's a great question. I can just tell you that we're using a load balancer and that is round robin.
Okay. Depending on load balancer, you can do some modified round robin that will take into account how busy a given server is. But yeah, that's the first thing I would look at. If you've got, if all your reports are roughly running the same amount of time, a round robin works really well. But if you have a long-running report and a bunch of short-running reports, you've got to do some adjustments for that. And a pure round robin isn't going to do it. It's the yeah, question.
Yeah. Affinity, yeah. You could affinitize, he's talking sticky sessions on the NLB. You could affinitize based on that. There are other optimizations we can also talk about is if your query is long running, if it's associated with the reports, instead of live data, you may want to cache it, or you may want to use a snapshot. Yeah. We'll get to some of those aspects a little later, but yeah. Those are some other.
But just a point. Affinitization is if you've got a report that is a session that's affinitized, it'll as it's going out, it'll go back to that same server. But if you're in a round robin and another report comes in, it'll go to the next node. Another report comes in, it goes to the next node. The fourth one that comes in is going to come back to the first node. And if that's already busy, that's where you need some additional capabilities in your load balancer. Yep. RS doesn't have that.
Yes.
Yeah. I'm sorry?
High availability. So we'll get to some of the high availability fault tolerance a little later. There's a disaster recovery section on that. Yeah. It's a little later down. We can definitely get to that as well, yes.
We'll get to that. So this is just to illustrate that essentially you've got a pretty linear scale. This is from an existing customer a few years ago that we published a case study on. And they went to 4 servers to support more concurrent users. And just basically adding more servers, basically more front-end servers. So again, just to briefly talk about the high availability, more front-end servers, that automatically gives you availability for the front-end server. We'll talk about the other servers as we go through the deck.
Is it fair to say, generally speaking, if you don't scale up and you just scale out, that even though you can serve more users, your report execution time is likely to go up?
If you just
scale out.
And you don't scale up, is it fair to say that users can predict reports that take longer to render, or stay about the same, or get faster?
I guess
because of the overhead that's involved in scaling it.
I don't think it can say that.
Yeah, we don't have any data that actually supports exactly the report execution time gets slower or something.
It should stay the same unless concurrency for a single report.
I mean, the overhead isn't going to be, like a report that takes 10, let's just say 10 seconds and you scale out. It's not going to go from 10 seconds to 20 seconds. Mm-hmm. It's some additional overhead.
The overhead you were talking about with the hops and all that, how does that manifest itself in terms of user experience?
Well, in its SharePoint mode, I think we measured it roughly at 400 milliseconds. But if you got a report that takes a second and a half, it feels to the user like it's like almost twice as slow. So a lot of it's perception. But as you start getting more and more hops, and if you get inefficiencies in your network, and we'll talk some more about that, as concurrency goes up, that contention can cause some issues. So, and you mentioned scale up. I want to move to the next slide because it addresses some of your points here. So the general approach that the CAT team has been recommending is start out by scaling up your front-end servers. This is kind of just scale up and scale out. You can get a lot of benefit from scaling up. We did some tests a few years ago, and we found dramatic improvements going from 4-core and 8-core up to essentially 16-core. Because commodity servers have gotten less expensive, scaling up to 16-core made a lot of sense. Then we added a second front end for redundancy. So we generally recommend scale up initially for performance. If you need redundancy, start scaling out for redundancy on the front end. But scale up is where we start on the front end. When I say front end, I'm already assuming that we're splitting the RS catalog from the RS front end server, which is the second point. Scale out, well, actually the third one, but scale out to multiple front end servers for performance and availability. Third point, use dedicated RS catalog servers. You have one catalog server for RS until Denali, and we'll talk about that. I'm not sure where we're talking about that. Let's hold that thought for just a second. So the RS catalog server, you have only one server, so your only choice there, if that is your bottleneck, and you need to identify if that's your bottleneck. We'll talk more about that as we go through the deck. Your choice for that catalog is to scale up for that server, and then you can cluster that for high availability. In SharePoint mode, you can use dedicated RS application servers and scale up or scale out your web front ends. And then you're going to look at your I/O because in any database application, I/O can be an issue. And network links, make sure you have high performance network links and multiple NIC cards. And we'll talk about each of those in some detail. You want to talk briefly about the catalog?
Yeah, so especially about SharePoint mode, since now you also have the SharePoint catalog, content and config databases as well as RS, you will definitely see RS heavily requires the database. So you want to be careful as to what's the traffic going to SharePoint as well as what's going to RS. You may want to either at least keep it in separate SQL instances, if not separate database servers, depending on the traffic you're seeing from the catalog database itself in SharePoint mode. From the catalog perspective, we will talk about the TempDB and RSDB a little later, and their specific, let's say, profiles of each of the databases, and you want to carefully separate them out or deal with them. And we'll come to that. We have a separate slide specifically dedicated to the TempDB and RSDB a little later.
Now, there's a lot of content we've published over the last few years. The first half a dozen are SQL Cat papers, and there's additional TechNet articles. We've got the whole series on scale-out architecture, report catalog best practices, reporting services, scale-out, performance optimization, disaster recovery, which covers, some of you talked about high availability and disaster recovery. There's a paper on that. We have a couple of slides on that as well. And some basically books, online articles in some detail. Later on the deck, we do have some other links on troubleshooting performance issues. But there's a lot of information out there, and these links are provided for your benefit. How do you know if you need to have a scale-out architecture? Well, if you already have an environment in place and you're already starting to hit limits and you identify you're already hitting limits, then you kind of know you need to at least add a second node someplace. We frequently, on a CAD team, people come and say, I want to design a system for 4,000 concurrent users or something like this, not even always knowing what we mean by concurrent users, because concurrent could mean each one's running a report every 30 seconds, 60 seconds, 2 minutes, and they call that concurrent. When we do testing concurrent, frequently every 15-second think time. We vary this. But so how do you actually know what you need? Well, you don't know. When you come and ask us, we don't know what type of reports, how much data you're pulling back, and all of these variables. Really what it comes down to, you've really got to test this in a test environment. There's a paper mentioned here. It does say Visual Studio 2005 with SQL Server 2005. The test harness that it talks about here is still, it's been updated for the newest versions of Visual Studio, and it works fine with the newest versions of reporting services. But you need to test your environment to see what kind of scale out you need, or you need to just roll it out there and be ready to add another node if your users are throwing too heavy a load at it. There's no cookie cutter answer I can give you to add it up and say, this is what you need. So now we're going to break down the individual components of this architecture and talk about them in some detail. The first one is the report catalog. So back to our architecture diagram, we're assuming we're scaling out. This is the report catalog. It's on a separate server.
So one of the things you definitely want to do is, if it's intensive, then the first thing that Carl was mentioning before is scale up. Try to scale up the database itself. Now, in addition to that, then what are the characteristics of the catalog versus the TempDB? So the reports, all the various items, the metadata, snapshots, subscriptions, history snapshots, these are stored inside the catalog. Now, whenever you actually render a report, the report server actually creates a temporary rendering of that report, and that is a temporary snapshot, which it actually stores inside the TempDB. That is generally a pretty large amount of data, and so you need to have good I/O between the report server and the TempDB. And so you definitely want to make sure that, we can go to the next one as well. So there are a couple of settings that you want to do in addition to having the dedicated catalog server is the session timeout for the particular, which is essentially the rendering of the report, beyond which the temporary rendering inside a TempDB will be deleted. So it's marked for deletion, and then after that there is a dedicated background thread that comes in and decides to clean it up, which is determined by another cleanup cycle minutes configuration setting. So you want to ensure that whenever you're measuring I/O, you take into consideration the traffic to the TempDB, which tends to be very intensive. And obviously, you can use the perf counters to measure CPU, I/O, and things of that nature to ensure the traffic to the TempDB is what you expect. If it's getting more, you want to ensure that you also monitor some of our session data that we are storing inside, along with the temporary snapshots. Yeah, you want to go ahead and add something?
The big point I'll make here, in many ways, we're talking about, if you're used to tuning databases, in many ways, this is just standard database tuning techniques, is make sure your RS catalog DB and your TempDB are configured optimally. A lot of it's going to come down to I/O, file placement, separate LUNs, things like that, which we'll talk a little more about, but it's standard tuning techniques for a database. This slide we've already talked about basically. There's a couple of common scenarios other than having a dedicated catalog server. Put the RS server and the catalog server on the same server instead of splitting them out. The other is to have the RS catalog and RS TempDB on the same server as your data sources. Both of those will cause contention as you get more concurrency, and you need to scale them out. Best way is to have a dedicated catalog server. And by the way, you cannot separate the TempDB and RS catalog. They have to be on the same server. So SharePoint mode, similar idea. And this is where you can talk about the new catalog stuff.
Yeah. So essentially, I think I covered a little bit where the RSDB and the TempDB, you want to separate it, at least separate SQL instances. That's one of the options that you can choose to do. We allow that even in the new Denali integration, where you can choose to create it in a separate SQL instance, so that SharePoint generally has a lot of DBs anyways created for them inside their SQL instance. So one of the things is create ours in a separate instance and monitor that separately. before you choose to either have a dedicated server or not.
But again, be aware, there is communication going on between the RS catalog and the content catalogs. So you may want to put them all on one server, or you may want to separate them out. It will depend on your environment, what else you're also doing on your SharePoint server. Do you have lots of other things on your SharePoint server, lots of other content databases, or is it just RS in SharePoint mode? May determine if you want to split the catalog server and the content DBs into separate servers. This is our standard I/O slide. Basically, this is for report catalog, but this is for any high-performant database. We've got a paper out there. Mike Rutherford on our team is one of our best I/O people. He wrote this paper based on many years of doing I/O work with lots of customers in our lab. More smaller disks than larger disks because the rotation speeds tend to be faster. You want to balance the I/O across all spindles. Separate your disks between RSDB and TempDB. Basically, you want a separate LUN for each database. You probably want to have separate disks in SharePoint. If you're putting your content databases and your RS catalog on the same server, at least use separate disks. Pre-grow your databases. They should never grow while they're under load. It's going to slow them down. Stripe them. RAID 10 is going to give you better performance than RAID 5. Any questions on I/O? I'm going through that a little quickly, but again, this is standard
Feel free
performance.
If all the servers are virtualized, I mean, that's our environment, as well as, I know we're doing VPOS, so that means all of our SharePoints are moving to the Microsoft Cloud, but we're going to maintain the SSRS instances internally. And so does that rate anything that you've presented so far?
Repeat that. So you're using SharePoint Cloud, but you're retaining RS internally. Your data is internal too.
Yes.
So you're going so your users are going from on-prem to the cloud to SharePoint, and then back to on-prem.
Currently not.
But that's where you're going.
Yes, that is the plan. So does that change anything in terms of consideration or flaws that?
Well, it's probably going to move your bottleneck to the network. Which means you're probably not going to be I/O bound. You're probably my guess. I haven't done this. You're probably much more likely to be network bound, and possibly processor bound, depending on what kind of reports you're running.
So should we just run SSRS in native mode? Do we lose really any of the benefits of having integrated mode then?
So I believe the question is like, you have BPOS, you want to have BPOS subscription. Now you want to also access the reporting services. So we don't have a solution as yet for the versions out there currently to answer your questions, from cloud trying to reach out on-prem, get your report data or SQL data. That is still being planned even on our side. And so for the current versions that we have, or even for the Denali version, you won't be just directly able to integrate into BPOS per se and reach out into your on-prem reporting services solution. You could come up with your own. That doesn't change the fact that, yeah, you could definitely come up with your own form of a proxy between your BPOS and reporting services, but any authentication or mappings that you have to do between your BPOS users and your on-prem users, that you will have to have a custom solution for as it stands. So, but we're still working out on our side as well to ensure we have a cohesive. We can definitely talk offline about plans and so on and so forth. Yeah.
And we do have a CTP of native mode RS in the cloud, but that's not really going to quite help what you're doing either.
That's reporting services Azure, yes.
Yeah.
That's not.
So we should definitely talk offline about some of this. There's a lot of stuff coming, but you're on the edge.
Yes.
Question.
Very general question. Is there ever a scenario where you restore the RS temp?
So generally, it is generally you back up and restore the data that, like your reports, your subscription, just stored in the catalog. You could choose to back up and restore your TempDB as well, but it depends upon how much are you okay with the downtime to start from scratch if all your temp data is essentially thrown away. It's not like you can't. You could choose to back up and recover, but it's still a large amount of data. that you will have to back up. And generally, it is real-time data is happening. So you will have to determine when you need to back up and how fast. So generally, the recommendation is it's throwaway data that you could, if you can tolerate the downtime, to actually come back and start from scratch. That's what you should consider.
It does lead into your next slide.
Oh, sure. So exactly, perfect question, perfect timing. So we would generally recommend backup and restore to avoid any data loss. Do that for the report server catalog. You need to make sure that data is long-lived. In SharePoint mode, one thing you do need to keep in mind is when you're backing up SharePoint, it doesn't automatically back up everything dealing with reporting services. So you should also separately back up the report server catalog that is in SharePoint mode and the encryption keys, just like you would for native mode, and then restore them all together. That's one caveat to keep in mind for SharePoint mode.
Until Denali.
Yes, good point. Thanks for the reminder. Yes, until Denali. So we have an inbuilt backup and restore story with SharePoint. So if you schedule a backup, either whether you use your PowerShell commandlets for backup and recovery, we do that for you in one shot with the entire farm. So I do show some of those aspects, by the way, in a previous session that you may want to look from a recording perspective. It's DBI 328. You may go back. When you get the recordings, I do cover some of those aspects in SharePoint mode for Denali.
And the other point at the bottom of the slide is, again, this is a standard SQL application. So you may need to pay attention to updating indexes, stats. There's some work that you can look at here to see if you can increase performance.
Is there any guidance for that? I've had a conversation with one of my DBAs about whether or not to do this, and he couldn't find anything. You know, it could be a function of his search, but you know, from Microsoft that says, should we include the reporting services catalogs in a standard maintenance plan, or specifically for?
I'm not a huge fan of the maintenance plans, but we've definitely seen in some of our CAT engagements that we've been able to do some performance improvements with stats and indexing. So.
But don't do it unless you need to.
That's been our experience. Chuck, you looking like you want to say something?
Well, I was just thinking your comment about maintenance plans, and yeah, I'm not a big fan of the maintenance plans either. But if you have like normal database maintenance that you do, like if you have a weekly DBCC check DB and all that stuff,
Include these.
you should be doing like
That, yeah.
check DB and that kind of stuff against these databases.
But yeah, we have seen improvements. Yeah, in the SQL CAT engagements are all large-scale engagements, high concurrency, large data sets. We can't tell you that this is going to apply across the board to every environment, but we've definitely seen the ability to improve it in the scenarios that we work in.
I mean, keep the health of the database. If you have other databases at the same time, don't exclude reporting services. Maintain just the generic health of the database. Obviously, that applies to our catalog too.
So after you've optimized your, you split out a dedicated catalog, we're going to talk about we've already talked a little bit in the beginning, is you can have multiple front-end servers. Multiple RS front ends with an NLB in front of it. You may need to consider a smart load balancer if you've got a mix of long-running reports and short-running reports. A round robin is just going to do what it says. This can be a software load balancer. It can be a hardware load balancer. And you want to, and we have it here coming up. When you set this up, the load balancer, you want to set this up with affinity. So the client basically comes back to the same server for a session. It can be IP affinity, but we definitely recommend cookie persistence as our recommendation. Keep it round robin in general for initial connections, with the exception of what we already had a question on. As you increase your concurrency, one of our other recommendations is make sure all of your RS servers have multiple NICs. one NIC for the communication between the clients and the RS server, the other between the RS server and the back end.
So the same dual NIC recommendation applies for SharePoint mode. Now, one hybrid also approach that I want to mention is in case of SharePoint, if you don't have an NLB, I had a gentleman I was talking to, I've seen a couple of scenarios with customers where if you don't have another NLB for the web front end, then you could essentially merge these two layers where you have the app servers and the web front end running. If you have a one-to-one, they could all run on the same server. And then you could essentially have like a loopback when the request comes to the web front end, routed to the local report server. And again, that way you could still have the NLB for the web front end and reapply that for the reporting services server. Just a hybrid for the scale-out architecture. And again, the dual NIC recommendation still applies to the app server where incoming traffic coming in from the request doesn't also conflict with the data source traffic or the traffic that needs to go to the catalog to retrieve the actual results of the query.
And the other point we made earlier, I want to make it again here, in Denali, that NLB between the SharePoint web front end and the RS application servers will not be needed because we're building a load balancer in the Denali bits.
Yep.
And it will be a round-robin load balancer.
If the WFEs are being deployed only to host the SSRS web interface, as well as host any of the document libraries where the subscriptions copy to,
Okay.
is there really a cost justification to separate them? So they'll still be deployed to the farm, but they're not being used for anything else. There's no team sites on them. I mean, they're just there to host SSRS.
So yeah, in that particular scenario, yeah, you could use the hybrid, merge them together, and just use them all on the same machine, each of the boxes. But yeah, make sure you have the loopback that goes from the web front end, so when the request is made, it doesn't go back to the main outer NLB.
Or you could reduce it to one web front end and 3, 4, 5, 6 app servers. Depends on your load and where the bottleneck is. This is just all the variations, which is why we want to have an interactive session and get your questions, because this is what you can do. But you may, for licensing reasons, for performance reasons, because you're only using SharePoint just for this, you can collapse some of this. Having multiple RS servers and multiple web front ends gives you redundancy in case any one of them goes down. So in general, you want to at least have 2 of each in some fashion. So if one of them goes down, you've got redundancy. So we've been talking mainly about performance. We're going to talk a little more about redundancy and failover a little bit later, but we're sort of working in here as well, is the pieces that you can, that are essentially interchangeable, which are the web front ends and the application servers, having 2 of each. If anyone goes down because of hardware failure, because service packs, because network links break, you're still up and running. So be aware of that as well as the performance implications.
So this is the one slide that Carl was talking about, report performance. Obviously, the key thing is get the data you need. Because internally, if the data set is really large and you don't need most of the data, it's data that you don't need to actually be bringing from the backend server. So filter out the data and also ensure that the appropriate users have access. So you don't have too many users trying to hit a report that they don't need to be seeing or rendering. That's one of the ways. Plus, obviously, the other things are caching of either live data. Processing options for a report are use live data, use caching, or use snapshots. So choose accordingly. If you have read-only scenarios, then maybe cache and snapshots make more sense than live data as well.
Yeah, our experience, both with the customers and in the lab, we've pushed this to quite high limits. And we're actually doing some more recently with some of the newest processors and solid-state drives out there. But we're still seeing the same basic thing, and that is once we apply this basic scenario, multiple front ends, multiple application servers, dedicated catalog server, we're finding the bottleneck moves to the back-end data source. And we're always able to move it here, and essentially without getting creative, you really can't, it becomes more difficult to scale out your data sources. You generally scale up your data sources and do techniques to minimize as you need the pulling of data off for live reports. Make sure you don't pull off too much data, caching like I said, but you generally scale up the server. If you want to scale out the server, you've got to do some other techniques because SQL Server Relational Engine is not designed for load balancing. We've talked about stuff in clustering, but not for load balancing. And a final point I want to make, we do have a feature in R2 which comes into play a little bit here, and that's shared data sets. One thing you can do with shared data sets is if you have users building reports, what we frequently see is they don't always write the most optimum SQL. So if you use shared data sets, your users writing reports can work off of shared data sets that are highly tuned by your DBAs. So they're very well-tuned queries. And we'll talk a little later in the deck if we get time to get to it, which we may. There's some techniques to actually look at your reports and go, this report, these like 2, 3, 4, 5, 10 reports, whatever, are my busiest reports. What's the problem? Is it rendering? Is it getting data from the server? Is it pulling too much data back? You can then go in and look at them. And if your DBAs can tune these, they can also reduce the load on the server. And shared data sets help you do that by separating the queries from the actual report. So performance optimization configurations, what can you do beyond what we've talked about in the internals?
Okay. So 64-bit hardware generally implies you have more addressable space. It does not necessarily always translate that, oh, I have a 32-bit, now I've gone to 64-bit, everything is going to just run faster. That generally is dependent on your clock speed. So that's one key point that you want to take out of here. And the other thing essentially is that from a 64-bit perspective in SharePoint mode, for SharePoint 2010, you don't have a choice. It is only x64. So those are some of the key points. Now, one of the benefits obviously is because of the addressable space, larger reports definitely you can view and export, and you have more addressable space from a memory perspective, in addition to just the addressable space. Yeah.
And it may enable you to handle more concurrency as well.
Absolutely.
But if you're out there shopping for your processors,
yep.
And you know your bottleneck is rendering, make sure you pay attention to clock speed.
So, report execution timeouts, these can be set as well. They control, by default, it's 1800 seconds, which is essentially how long do you want the report to run before it times out. Now, if you have long-running reports that you really don't want to run that long, you may want to shorten it. Also, you could choose to schedule the longer-running reports that require more resources and they run into bottlenecks. Schedule them accordingly. And when you need to deliver, whether to the SharePoint document library or whether to email, again, you can use appropriate scheduling, generally after hours if they're really large reports. And that way you can efficiently use the time when people are actually working and using the report server, they want to render real time. So that's the key point. Interactive use. If you don't, for exporting and other actions, consider a scheduling or background processing means to actually have those operations performed. So the other aspect that we see is we allow you to store a history snapshots of reports. Sometimes customers tend to overload this operation as archiving and try to keep a lot of these reports, which essentially increases the size of your catalog. One of the recommendations is at a certain period of time, you want to purge the number of report history snapshots that you have. We do provide a global farm level property to actually, currently, by default, it's infinite. There is no limit. But you can choose to set a limit. It's at the farm level. In native mode, we have the UI where you could actually do it even at a single report level. So keep that in mind, especially when you have large reports. Snapshots for them are going to just keep on increasing the report server catalog. And so
that's also where we've seen the benefit of indexing in particular. As people allow their catalogs to get quite large, they will start to slow down. Indexes will help.
So with Report Server 2008 onwards, we introduced the ability, before that, obviously a lot of folks, if they were using 2005 as a Report Server, you would see some of the out-of-memory exceptions that you used to get. We removed the memory bottleneck in 2008 with a re-architecture, and we have certain memory thresholds that inside a process that we observe. And so default is we take 60% of available memory, and between 60 and 80%, we have certain thresholds that we respect, and we want to make this is our scale mode that gets that was introduced in 2008. Full memory beyond, if it starts consuming more than 80%, then we start aborting requests, and we basically do not take in until we can reclaim more of the memory. So these are memory limits that you can configure inside the rsconfig file. And you can try, and based on whatever performance, whatever scale needs that you have for reporting services process, you can test it out and determine what meets your organization's needs best in these terms of memory configurations.
Speaking of config files, one of the things to think about, we came up with one of the questions here, if you have multiple RS application servers, you want the config files to be identical in most cases.
So yes, so as it stands today, for native mode as well as until version 2008 R2, if you have scale out, then you want to ensure your config files are identical, and it's generally a manual operation. In Denali, for SharePoint mode, we have overcome these abilities where we can now use PowerShell. For example, one of the customers had a scenario where they had different extensions registered in their config files. So in Denali SharePoint mode, we have a PowerShell commandlet where you can edit the config extension, and that gets replicated across to all the various service applications. You don't have to manually go in and edit the config file. One caveat, it is not yet there for native mode. So that is on our to-do list, long term. So
one other point that came up, is anyone here still running reporting services 2005? Because everything we're talking about so far has been 2008. Okay. Do you have specific questions on 2005? I have a couple comments I can make in general. But this has all been 2008 focused, or Denali. Question over here, anybody?
Yeah, the only reason we've kept ours is for strong authentication, because we can tie back to IIS for RSA token through ADFS. So that's the only reason we still, and that we just haven't replaced them. So we have a mixture of all.
I see.
The reason I say that is I'm trying to remember the details of this, but we hit bottlenecks on the front end at a much lower number of users, and we had to do much more scale out because of the architecture of RS being tied to IIS. And so the scale out story is a little, and we have a paper on SQLcat.com about the 2005 scenario too. But the limits on how much traffic can be handled by a single web front end or RS front end server are considerably lower than what we've been talking about here.
Now, from a strong authentication perspective, you may want to consider, look closely at a Denali architecture in SharePoint mode. That is, it is now it's hosted inside W3WP, IIS, and SharePoint. That may be an option to consider. I do believe with the new architecture, yes, there are different ways to actually deal with ISA proxy. We can have a follow-up on that. There are some specific servers that you could actually put in front of reporting services to do some of the ISA translations. We can have a follow-up on that to try to see if there's a solution for the native mode. I'm assuming you're using native mode for 2005, right? So yeah, we can definitely look into some of those aspects where it is not handled with reporting services, but there could be a layer that you could add in front of reporting services for 2008 or 2008 R2 to try to solve some of those problems.
And a point in this slide that we put it here because I'm not sure where else to put it. We've been talking about all these different places that you can make improvements in performance. Every time that if you got a working environment and you've got some scale problem and you do this piece of scale out or you do this thing with the report catalog or this thing with memory, the bottleneck's going to keep moving around, and you just got to keep paying attention to it because it's going to keep moving. It always will. So we've talked a little bit about some of the redundancy. We're going to talk in a little more detail here in this couple slides. We have a whole white paper on SQLcat.com about this. This is what we've done at an actual customer site. So we've got a primary data center and a data recovery site geographically remote. And we've got a content switch between them. So when the users come in, they basically hit the content switch, and by default, the content switch is going to route all users to the primary data center. In this scenario here, we've got the primary data center. We've got a single, just for the purpose of the diagram, we have a single RS front-end server. And if you want to make that redundant, we've already talked about that. Just do multiple RS servers. On the back end, the RS catalog, we've clustered this one in a failover cluster. And then in a remote site, we've got a second RS front-end server, and we have another failover cluster for the RS catalog back-end server. We've got fiber connectivity between the sites to keep latency down. We've got identically named instances. It helps us in case we need to change connection strings. We can use aliases for that, and identically named instances helps set that up. We can actually also load balance between the sites if need be with that content switch. We can route some users to the secondary site if the primary site gets overloaded on the front end. Again, that works because we have a high-speed fiber network between them. So what happens here? If any of the front-end servers goes offline, it basically we have a second front-end server at the remote site. Again, extrapolate this out. There could be multiple front-end servers in the primary and multiples in the secondary. There's no actual data being stored in there. So if that fails, the content switch can detect automatically that it failed, or you could take it down for maintenance and use the secondary. This is all automatic. There's no data loss. It just happens automatically. And assuming the high-speed network, your users aren't even going to detect a problem. Let's say you've got a problem with your RS catalog in your primary, that server goes down, or you've got some problem like that. Essentially what happens is this will automatically fail over to the passive node, and the passive will become active, and it just keeps running.
Now, is there an IP name that we use in this case?
Your cluster has a virtual IP address for the cluster, and that's what RS is connecting to.
That is what RS is connecting.
Yep. Good point. And the third variation is if your entire cluster goes down in your primary, we've set up essentially async mirroring between the primary and the disaster recovery site. We're using async which gives us some possibility of losing a little bit of data. But in general, RS catalog servers are not that dynamically changing, not like an OLTP environment. In our experience, when we tested this with the customer, we had basically zero data loss. There was not any problem with that. But this is a manual failover to the remote site. And we've got this running, and we've got a white paper on it, and it just works. So I know you had a question back there on disaster recovery and high availability. We've addressed that several points today. Does that cover your concerns, or do you have more questions?
Yes, I have a question. What about the lower cluster? It fails the storage.
Failover cluster and the storage fails?
Yeah. In our case, we generate new RDLs every 10 seconds. We dynamically generate RDLs.
Okay.
Every 15 seconds, we generate new RDLs. And manual failover is not a solution. Failover cluster, yes, it can be implemented, but if the storage fails, we're losing all the data.
Well, okay, so if you've got RAID 10, you're talking about the entire RAID 10 array is failing, or just a single disk?
No, all enclosed.
So you're talking about this scenario here. Sorry, wrong direction. This scenario here where this entire site goes down.
Yeah, but
Okay, so with async mirroring, if you're generating RDL every 10 or 15 seconds, I'd have to test that out. Async may be sufficient that you're okay, or you may need to change this to synchronous mirroring. Synchronous mirroring is going to solve that, and you're going to have to basically, the synchronous mirroring has a little bit of performance hit, but it's going to solve that problem. Chuck?
very complicated architecture. Maybe in Denali it will be a little more easy to implement the solution.
Chuck?
Will our connection strings in RS support the failover partner keyword?
This is for automatic mirroring failover. That is not in the plans for Denali as it stands. So it will still be manual, as Carl is indicating here.
But if you're generating RDL every 10 to 15 seconds, yes, this is still the best solution with possibility of looking at synchronous instead of asynchronous mirroring. There is nothing else really that's going to solve that today. Other than possibly if you're generating it that frequently, you could push it to both locations yourself and use asynchronous.
The other option that you would have, and it adds a lot of expense and complexity, is a multi-site failover cluster where you have disk on both sides and servers on both sides, and then the IP address, that virtual network name that lives with the cluster, will move from site A to site B, so your report connection strings wouldn't need to change. But as I mentioned, it's a lot of complexity and a lot of money.
Yes, you had a question?
I have a need to script the configuration of a reporting service. And we've had to do that using WMI. I'm kind of hoping that in 2008 there would be some PowerShell command. Is there anything else?
So the question is, do we have PowerShell commandlets? We do have it in Denali, but it's only for SharePoint mode. It's only for SharePoint integration mode. We still have WMI for native mode. And so, yeah, you unfortunately have to go to every machine, set it up for every machine, configure every machine separately. That limitation still exists in Denali for the native mode aspect of reporting services.
Other questions? We've got some more slides on troubleshooting tips about how to identify where your bottlenecks are and so on and so forth. But this is sort of the end of the architecture section. So any questions you want to?
We're going to have an open forum for anybody to ask any questions about the architecture or.
How about just from a process side point? Again and again, because our environment is much more secure, and we don't really allow users to browse data, the workaround has been an extreme abuse of what they call reports. They're really just data dumps, copying across literally the world and multiple continents so they can get the data into Excel. And we see 7,000, 8,000, 10,000 subscriptions to these massive data dumps. So we just keep scaling out and scaling up. And I can't point, I mean, when the questions come up, well, show us one good white paper on governance for what qualifies as a report. And I can't. I don't see anything. So we have reports from 100,000 rows to 2 million rows with 650 columns. I mean, again, I mean, we don't have much governance there.
Do you have the ability to time shift?
I don't know. I mean,
I mean, do you have times a day when it's really, really busy and other times when it's not? Or is it?
Well, the problem is the reports themselves, that just the mere execution of them makes it a bad time.
Right, but if you could say those reports only run once a day at midnight, and you schedule them.
How can you do that? You manually just go through and audit the subscriptions each day that are created for these reports, and you change?
So you definitely raised a gap that we have, where at an IT level, we don't give you, here are all the subscriptions that you want to manage and ensure that they are controlled accordingly. There is a way to, one of the ways you could consider would be via enforcement. Don't allow users to create schedules other than the ones shared and given by IT, okay? That is something you could choose to do, and to regulate customers whenever they're creating a subscription. You basically can cancel any of the jobs dealing with the subscriptions anytime during the runtime, but you'll have to monitor it, and you will have to, there will be certain manual or programmatic ways. There are APIs to actually do canceling. But we don't have that, you're right, we don't have that UI experience for the IT admin to go in and control that. We don't have that as yet. So that is also, again, one of a good to-do action items that we haven't gotten to as yet in Denali.
You can easily go in and identify which ones are the offending ones.
Yeah.
But that's about as far as we go.
Right.
Yep.
Yeah, thank you for helping me identify them, but that's
Yep.
here are best practices versus here is absolute governance, and once you move outside of this, we're going to have to look at SQL drops, we're going to have to look at SSIS packages that copy this data, and you guys are going to have to figure out what to do with it, but you can't use our shared environments anymore. I don't know what else to do, but there's nothing that I can point to that Microsoft has published that I can say, see, here are best practices,
Yeah.
and this is what we based our conclusions on.
You could
do that.
You could have multiple, use one RS environment for certain types of reports and another one for other types of reports.
Yeah, we already do that.
Yeah, so you already, that's the other thing you, okay. That's about all we got on that one.
Good point. Oh.
So troubleshooting tips, overview. Reports can take a lot of time, a lot of memory, a lot of CPU. So you can run out of memory. There can be rendering errors. There can be internal errors. How do you identify them? We have RS logs. The execution log, service trace log, tells you a little bit about where they are. The Windows application log as well. Couple reference links here. Where to find more detail about these logs. You want to look at memory consumption, application domain, recycles, etc. There's some resources here for performance counters. Particularly want to point out execution log view 2. And Robert Bruckner from the RS team has some great blogs out there. One in particular goes into some detail about how to use execution log view to identify reports that are having problems, which ones are rendering bound, which ones are bound and getting data from the data source. Once you know where the bottleneck is, you can look at, do I need to try to fix the report because it's pulling too much data back? Do I need to scale up my RS server? Do I need to maybe think about scheduling this or caching it? Because you look at the reports that are the difficult reports, you might look at it and go, well, they run this report every morning at 8 o'clock. And the data hasn't changed since midnight the night before because that's when the data load occurred. Run a job to cache that. So that one never hits the data source. So there's techniques like this to look at. Next to the bottom bullet points is a good one we've run into, and that is it's difficult to identify what report is running now. Once it's done,
Yep.
I can identify, but while it's running, it's difficult to find out what's running. You can look at the list jobs with the SOAP API. That's about the only one I know of to find out what's actually running at the moment. Again, back to basic database tuning. You can look at what's going on in a report server database with Profiler. You can also look at what's happening in the underlying data source to see if you've got problems with execution plans and so on and so forth in your actual data source, once you know where the bottleneck is. And this is just showing the syntax for querying the execution log 2. Ordering by time start helps you identify what are my long-running reports. I already mentioned the caching. You can identify which ones are already returning from cache, which are live, which are execution snapshot. Again, this is for all the reports that have finished. What are the most popular ones? Which ones take the longest? Which ones have huge output, like PDF? Can you time shift these? I mean, these are all the things you can do. You can just keep adding hardware, scaling up, scaling out. But you can also identify what can you do beyond that, and that's what this is focused on. So there's a MSDN article here on how to adjust the report size in memory, adjusting schedule concurrency. This is really for isolating problems. You can reduce the amount of concurrently running reports. If you get a report that it seems to be causing you a problem, it may be an interaction with something else. So you can trying to isolate where the problem is. You can reduce this down to one report running and see where the problem is. You can use that for also measuring what the true impact of a given report is. There we go. Very common problem for authentication is a 401 error. There's some problem getting credentials through. This is not a talk about authentication. I've given a talk on SharePoint authentication, particularly in the past. It's a complicated topic. But if 401 error occurs, we've got a nice, for SharePoint mode and for native mode, we've got some long papers out there on how to set up authentication. Generally, this is going to relate to multi-hop problems with Kerberos. If anyone wants to talk about multi-hops and Kerberos, see me offline. I can talk for hours on that topic. I'm not going to do it right now. And there's some variety of logs here to look at. This really is I'll show something more on this. This is really just for your reference of where you can go to find more information.
Just about Kerberos, one of the, obviously we can definitely talk about issues on how to set it up and set the SPN and the constraint delegation. One quick FYI, in Denali, you don't have to use Kerberos for the report server service. It uses claims, so that may be one of the options that you may want to consider long-term as well. Just want to throw that in.
And as long as we're throwing things in, there is, if you're running from reporting services into analysis services, there's a new capability coming through SharePoint mode to actually not require Kerberos. And we'll talk more about that in some upcoming papers. Again, if you want to talk about that, see me offline. It's a specialized scenario, but it does definitely, it will help in actually in a lot of scenarios involving analysis services, which, by the way, will also be anything involving Crescent. And I mentioned this earlier, your queries against your relational engine, make sure basic SQL tuning, your query plan optimization. Spend some time. If your bottleneck is in your data source, again, I mentioned earlier, once we do all of our tuning in our scale up and our scale out and our architecture of our RS, every major client we've worked with, we've always been able to move the bottleneck into the actual data store. So then you're back to tuning the data store, tuning your queries that are coming into the data store. And we mentioned here drop-down parameter lists. They can be a bottleneck. I've had one customer in particular I worked with. They were so incredibly upset with reporting services. It took a long time to run these reports with analysis services, and they were screaming. And when it really came down to it, we looked at it, the report ran beautifully. They had to pick, like, I forget what it was, like 12 or 14 different parameters before they actually submitted the real query. We basically did some work we took two approaches, and they did actually variation on both for different solutions. One was they actually cached the data, a separate data set for parameters, and they cached that data set. The second one they did with analysis services in particular, they took all of the strings that they would provide in the parameters for the analysis services queries, and they took those strings and put them into a SQL table. And once the parameters were decided upon, they did a string substitution to put those back into MDX, so what was submitted was the actual MDX string. But they didn't pick the parameters by querying the analysis services database, which happened to be a very, very, very large database. But the problem was not the report itself, but they didn't do their analysis initially until they came to us. And then once they analyzed it, it wasn't the report, it was the parameters. So again, identify where your bottleneck is. And if you've been here all week, I'm sure, how many people have not seen this slide? Yeah, okay. End of the week, here's some resources. I'm not sure what they're going to help you. Actually, this will help you for beyond this tech ed, but you've seen this slide a bunch of times. So thank you. We'll be here afterwards for questions.